I've had my FT817 ND for a couple of months now, and last week I took it out for a portable QRP session on Cothelstone Hill in the Quantocks, a hill range in the southwest of England. To do this, I had to power it with batteries, and I've been researching and experimenting for a while to find the best option for powering the FT817, both at home and outside. So let's take a look at what I've found out, including how to calibrate the battery voltage shown on the FT817 display. The Yaesu FT817ND can run on external power from mains or battery, or its own internal battery pack. It comes supplied with a battery tray for 8 alkaline AA size batteries, giving a maximum 12 volts. They also originally supplied a rechargeable NiCad battery pack with 9.6 volts and 1000 milliamp hours capacity, later followed by nickel metal hydride battery packs at 9.6 volt with 1500 or 1900 milliamps capacity. The connector for this battery pack has a green wire which prevents trickle charging when the alkaline battery tray is connected. I did some tests with both of these options, the alkaline batteries and the rechargeable ones, but before I look at that, let's check the specifications and the actual current consumption of the radio. The manual says the radio should be externally powered at 13.8 volts plus or minus 15%, and it also gives an overall operating voltage range of 8 volts to 16 volts with available power of up to 3 amps. Let's set the power supply at 12.5 volts and a maximum current of 3 amps. There we are. I've connected the output of the FT817 to a dummy load via a power meter, and I've set it to the 20 meter band and CW, which is where I'm most likely to be using it, with maximum power output of 5 watts. On receive, the current drawn is specified as 450 milliamps, and on the display we can see it's actually drawing around 390 milliamps. When I transmit, the current is specified in the manual as 2 amps, but let's have a look. On the display it's actually drawing around 1.9 amps. Let's look at that again. Yep, just under 1.9 amps. Originally, Yaesu supplied a charging power supply which is not powerful enough to operate the radio. It's meant to be used just for charging. But they recommend a fully specified supply to run the radio and charge the internal pack at the same time. I've found the answer to my first question about power, choosing a suitable option for running it at home from the mains. As far as I can tell, 12 volts is a good voltage to operate at. There's no need for any more, and I'm guessing any extra voltage is dissipated by the voltage regulators as heat. So I run mine using one of these Zolt power supplies, which is not noisy and does not get hot. It's also small and neatly designed. I've swapped the original connector for one that fits directly into the FT817 without an adapter. So, having found out about power consumption and sorted out mains power, let's take a look at battery and portable options. There's a lot of discussion online about the various battery options that are available or were available, and the choices seem a bit puzzling until you remind yourself that this transceiver is now over 20 years old. Battery technology has moved on hugely since the early 2000s, and there are better substitutes available now for alkaline cells, NiCad rechargeables, remember those, or nickel metal hydride battery packs. Let's try 12 volts from the alkaline battery pack to see if it actually works. I've got one here, and it's a real squeeze to get it in the case, so I've just popped it onto the bench for a moment, and I've turned it on and it's receiving well enough. In fact, just now I could hear a CQ coming through even from my dummy load. That's amazing. So it does work. It tends to default to 2.5 watts, and if I transmit, will it still work? Yep, it's still working on 2.5 watts. Let's try changing the power. And obviously going down is fine. So now the flashing indicator says it's 5 watts. and if you look at the meter, it's a bit less power than I had it on earlier. In fact, the battery indicator says 10.6 volts. I think that's dropped fairly rapidly since I plugged it in just 1 or 2 minutes ago. But I think it works well enough to receive. If you wanted to have a little receive, I think on transmit it would be very limited, and it's not really my intention ever to use a battery pack like that. It's just a curiosity. So let's take a look at some of the other options as well. How about the internal battery pack? I can't demonstrate it just now, but I used one of the nickel metal hydride ones for a while. It worked well and gave me a decent session, but it does have a couple of issues. The main one being it takes a long time to charge and it cannot safely be left in the radio. And this is made more difficult by the connector, which is small, difficult to remove and likely to break over time. So I decided to look for a more modern solution, and the options include external battery packs, usually lithium based and quite bulky, lipo blocks, the type used in drones. They're good too, but they need a way of connecting and housing, and they need very careful handling and can be dangerous. Some people use solar panels when they're mobile, which is great, and of course if you're in a car you can power from that or from a backup supply charged at home. I wanted a battery option that I could house in the radio and that would give me a decent session of operation with minimal recharging time. I also wanted to be able to disconnect the batteries and store them when not in use, and I didn't want to use the internal battery wiring. I just want to bypass that. The option I chose is to use 3 18650 cells, which are slightly larger than AA cells. I purchased 3 Samsung batteries rated at 3000 milliamp hours. Fully charged, they give me 12.5 volts, and in operation I run them down to about 11 volts, the nominal voltage. At 300 milliamp or so consumption for receive, they would give me several hours of operation if fully discharged, but of course transmitting would reduce that time. For CW mode, of course, the amount of time the carrier is on is relatively small, but for voice modes, obviously more power would be used and the power use time would be reduced. It's not good for these batteries to be over discharged, so I aim to use them until they're down to their nominal voltage. And I found that using these batteries for portable operation, I had only used about 1/3 of the available power in the range I set after an hour and a half running at 5 watts, and that included some SSB. It would be easy too to take a second set of these 18650 batteries, so this seems a really good solution, even for a whole day's operation. They're easy to charge. I use an IntelliCharger, and let's hold them up. They're a wonderful bright pink colour. For my prototype modification to the FT817, I put the batteries into a series holder and soldered on a suitable connector cut to length. The holder fitted perfectly into the battery bay, and I designed and printed a simple cover which is held on with 3 bolts into the existing threads. It's hardly noticeable when fitted. To connect the battery pack, I just plug it into the external supply socket. I decided to just sidestep the internal battery connections to avoid any potential problems. The batteries are easy to remove and replace, and now that I've tested this idea and seen that it works, I will add a switch and a fuse. And just a word about all lithium batteries: they can be dangerous, so if not being used, keep them in protective packaging. I keep my drone batteries in metal tins when I'm not using them. Oh yes, before leaving the topic of battery power, one thing I noticed at first was that the display voltage on my FT817 did not match my power supply or battery voltage. So here's the reason and the fix for that. Whenever you go into the service menu, something only to be done with extreme caution, if you save the settings, then you may change the voltage display calibration. So to fix this, attach the radio to a known voltage. I'll choose 12.5 volts to match my batteries and start it up with the service or soft calibration menu. That's done by holding down the A, B and C buttons together and then powering on until the radio makes the special sound. Then go to menu 17 and set the value to 10 times the voltage. So for 12.5 volts, this needs to read 125. Then hold the F key to save the settings and the voltmeter should read the incoming voltage correctly. If you go into this menu, be very careful not to change anything else unless you're sure you want to, and you do so at your own risk. I'm really pleased with my portable battery-powered FT817 rig, so having looked at power in, let's now take a look at power out. In previous videos, I've shown how to measure RF power output using an oscilloscope, but today I've hooked up my FT817 to my newish MFJ RF power meter via my homemade dummy load. And if you get one of these very popular radios, it's worth checking the output power because some people ramp these up very high indeed, maybe to as much as 10 watts. I don't think that's a good idea, it's just a personal view, as I think it puts unnecessary strain on the components and shortens the life of the radio. If I wanted more power, I would get myself an amplifier or make one, or maybe buy another transceiver. So let's take a look at these power levels with the FT817 and its 18650 battery pack fitted. So starting with 5 watts, yep, there we go, that's good. And then 2.5 watts, yep, looks good too. 1 watt, spot on. And half a watt or 500 milliamps, there it is. So they all seem really close to the specified power output. That's great. I've made my power readings now using CW on 20 meters, but it's worth noting that FM has a different signal path to the other modes. So if you get different readings on FM to say CW or SSB, it may be that you have a problem before your final amplifier. There are a couple of excellent videos about fixing issues related to this by TRX Lab and W2AEW on YouTube, and I'll put links to those in the description below. And of course, your real output power is dependent on how well your transceiver is matched to your antenna. At the moment, I'm using homemade resonant antennas on 1 or 2 bands. They're easy to make and they have a 3D printed housing which includes a small matching transformer. I've enjoyed making this short series about the FT817. Its successor, the FT818, has just been discontinued, but there are thousands of these radios still in service, and I hope the pre-owned market will remain strong for years to come. I haven't seen anything with such a range of options all in one small portable package. I'm really pleased that I've now got mine set up just as I want it to be, both for home and for mobile expeditions. Other videos in this series include setting up your FT817 for great QRP operation, how to replace the finals board in your FT817, and how to fit a SOTA-beam CW and SSB filter. And I'll put links to all of these in the description, along with my other videos, of course. So, thanks for watching. I'll be back with more videos soon as ever, and now I'm going to check out what's happening on the HF bands today.